Bismillahirrahmanirrahim. Dear student, today we are learning about the polyatomic ions. As we know that the polyatomic ions will be either a positive ion, like in case of NH4, which carries one positive charge, or it will be a negative ions, like in case of NO3 or SO4 or CO3 and so on. So in today's lesson, we will discuss how we will name these polyatomic ions. In this case, we will focus on the negative ions, the negative polyatomic ions, and we will focus on oxyanions. Oxyanion we will discuss right now. The polyatomic ions that contain oxygen are called oxyanion. For example, if we are going to talk about the NO3 negative charge and NO2 negative charge, both of these two polyatomic ions are made up of nitrogen and oxygen. But the only thing that is different in these two examples are the number of oxygen atom. In the very first one, there are 3 oxygen. In the second one, there are 2 oxygen. So the difference in the number of oxygen of these polyatomic ions will gives us a new dimension for naming of these polyatomic ions. The polyatomic ion that contains more oxygen, these polyatomic ions names ends with ATE, while the polyatomic ion that contains less number of oxygen, their name ends with ITE. The name of NO3 will be nitrate ion. Nitrate ion, while the name of NO2 negative would be nitrite ion. Dear student, if we will focus the polyatomic anions over here in this figure, you can see that if I'm talking about chlorate, you can see that number of oxygen in this chlorate ion are 3, while in case of chlorite, that is ITE, there are 2 oxygen. Now the if there are less number of oxygen, the name will end with ITE. If there are more oxygen, the name will end with ATE. Dear student, the ClO2 is known as chlorite, while ClO3 is known as chlorate. The names end with ATE. Now over here, the question arises that if we have a fewer number of oxygen than this 2 over here, like ClO, this is also a polyatomic anion. So what will be the name of this anion? If you have this sort of condition, you have to understand that the parent's name will be the same, chlorite. But before the chlorite, you have to use the prefix that is hypo. Hypochlorite. You have to use the word hypo. Now, if we have oxygen more than the ClO3, like this one, ClO4, 1 negative, and this polyatomic anion exists. So at that time, what you have to do, you have to understand that the parent name will remain the same, chlorate, but before the chlorate, you have to use the word perchlorate. So if you have 1 oxygen, hypochlorite, in case of this polyatomic ion, if there are 2 chlorite, 3 chlorate, 4 perchlorate. We have 2 ionic compound over here. The very first one is AgNO2. The second one is AgNO3. The name of the first one would be silver nitrite. And the name of the second one would be silver nitrate. Dear student, we completed the nomenclature of the binary ionic compounds. And now we are discussing about the naming of binary molecular compounds. Molecular means the covalent compounds. In this molecular compound, let me tell you that when we are going to name any sort of covalent compound, we will focus two set of system. The very first one is this stock system, this stock system of nomenclature. The second one is known as the prefix system of nomenclature. The stock system of nomenclature deals with the oxidation number of the elements. So regarding the oxidation number, we will discuss this one in the next section of the same chapter. Right now, we will focus on the old system of nomenclature that we call it prefixes or prefix system of nomenclature. That if we have a chemical compound that is CCl4. So if you look over here, there are 4 chlorine attached with a single carbon. So the name of this this compound would be carbon tetrachloride. Carbon tetrachloride. Now look, the word tetra over here is a prefix that is used for 4. And if there is only, you can say that if there is only one element, let in case of CO, we can say that this is carbon monoxide. So the prefix over here is mono. Mono means only one. We have one oxygen here attached with carbon. And if we have 2 oxygen attached, we can say that it is carbon dioxide. Now the word di over here is used as a prefix. So in the old system of nomenclature for molecular compound, we are using prefixes. The prefixes that is used in this the old system of nomenclature for molecular compounds are mentioned over here. For 1, we are using mono. For 2, di. For 3, tri. For 4, tetra, and so on. So these are the prefixes that we are going to use in this chapter. Dear student, if we have a compound like this one, P4O10, you can see that the first element, there are 4 phosphorus and 10 oxygen. So if we have this sort of molecular compound, so can we use the prefixes for the first element? The answer is yes. So look into this one now. Prefix needed if the first element contributes more than 1 atom. So the name of the first element is phosphorus, and there are 4 phosphorus over there. So we can say that tetraphosphorus means, tetra means 4. We have 4 phosphorus, and it is going to, over here it bonded with 10 oxygen. So for oxygen, for 10, we are using the prefix deca, and it is attached with oxygen. So you know that the end name of any anions will end with IgE, oxide. One thing you must understand that you have to, remove the end of this one that was A, the deca. So you don't have to write A when you are writing it with the second element in this compound. Same for mono. For example, if we have a CO, we can say that it is carbon mon and oxide. Here we remove the O of mono and it would be carbon monoxide. If we want to give the old system of nomenclature to this molecular compound, it would be like this one. For N2O, the name would be dinitrogen monoxide. Di means we have 2 nitrogen and 1 oxygen. For the second one, you can say that it is nitrogen monoxide. Only 1 oxygen is there. For this third one, it would be nitrogen dioxide. 2 oxygens are there. For the third one, the name would be dinitrogen trioxide. Dear students, some covalent compounds do not consist individual molecules. Instead, each atom is joined to all neighbors in a covalently bonded in a three-dimensional network. So there are no distinct units in these compounds, just as there are no such units in ionic compounds. As in case of sodium chloride, I told you that the same NaCl repeats itself in three dimensions, making a crystal lattice. Same over here now. And the subscript in the formula for covalent network compound indicates the smallest whole number ratio of the atoms in the compound. So we have an example like SiO2. It also makes the same sort of network. We call it silicon dioxide. And many other examples are here. That is silicon carbide and trisilicon tetranitride. The last part of this lesson, it deals with the acids now. Dear student, acids, it has a distinct type of molecular compound. So most acids are used in the laboratory for different sorts of chemical reactions. So in laboratory, these acids are classified as either binary acids or oxyacids. The binary acids are the acid that contains two elements, and usually these two elements are hydrogen and halides, group 17 element. While in terms of the oxyacids, it consists of hydrogen, oxygen, and any third element. If I will give you some examples over here for binary acids, these are hydrogen and a halide, chlorine, hydrochloric acid, hydrobromic acid, hydrofluoric acid, and so on. In case of oxyacids, if I will give you the example of H2SO4, look, this one contains now hydrogen, oxygen, and the third element, that is sulfur. And HNO3, this is a nitric acid. Over here, it contains nitrogen, hydrogen, and oxygen. And H3PO4, phosphoric acid, where you can see that it consists of hydrogen, oxygen, and phosphorus. The acid and the alkali, they react together and they give us salt and water. This reaction is called neutralization reaction. So if I will give you one example over here, the alkali, that is sodium hydroxide, when reacts with hydrochloric acid, it gives us sodium chloride, that is a salt plus water. This reaction is called neutralization reaction.